Hello friends, my name is Olivier Mubito from IPRS Kigali, and today's situation, it's a stamping machine that needs to be stamping the parts or the papers which might be used in workshop or in the library. So we are still in this design and the construction of electromagnetic control parts or circuits. So we are in part 4. So how does it work? Parts are to be stamped with a stamping device. By pressing 2 push button switches, the die is pushed down and the part is stamped. So this is the die that goes down to stamp. When the stamping pressure has been achieved, the die is returned to its start position. It means after stamping, it has to return to its start position. So what causes the die to go for stamping? It's this cylinder, which is 1A. It is the one that forces the die to go for stamping and to return to its start position. And then we're going to analyze why 2 push button switches. I think it's all about security measures. Suppose that you are an operator of a machine, you are in the workshop, and maybe you have the visitors that they come to visit your workplace. So there is a machine that has got 1 push button to start. By default or accidentally, one among the people who came to visit your working place may activate the machine without knowing what he is doing. So it's better to fit a machine with a security measure like 2 switches that need to be switched on in order to activate the machine, which means accidentally the 2 switches will not be activated at the same time. So hope you understand the purpose of using 2 push buttons. It's the security measure. Now, why the stamping pressure here? It means the stamping pressure, it must be achieved for the die to return to its start position, which means when the pressure is achieved, the system should go off. How does the system know that the pressure has been achieved? It's by installing a sensor. When we install a sensor here, it will be sensing the amount of pressure that it receives. And if you have set the 5 bar or 2 bar, it will switch on or it will switch off. So it will help you to control the system depending on the pressure that we have set, which means we need to go to pneumatic. So here we go. We need cylinder. It might be a double acting cylinder or a single acting cylinder, and I prefer to use a double acting cylinder, and I increase the length up to 4, and we go with a double acting cylinder. And since it is a double acting cylinder and we are in a pneumatic, so it goes with a directional control valve that has got 5 port. So this is the one with 5 port, and then we link the ports to the cylinder, and then we need to find the supply and the exhaust. So this is the supply, it goes to the central port, which is port 1, and this is the exhaust 3, and this is the exhaust 5. So we said that we need a sensor to be sensing the pressure. That's why we have to go to sensor, and then we find pressure sensor, and we call it PS as a tag name. Let us rotate for a better layout. If we rotate here, now we are going to choose what to display, the information that need to be displayed. So we cannot display all of this information, so I prefer to display that pressure. The name, it's a tag name like a PS that will be used even in the electrical control circuit, and its name, so that the viewer will understand or will remember that it's the pressure sensor. But I can also display the switching pressure if we need, and then we have to apply, and we go to assign now the switching pressure. I need to set this pressure into bar, and let me set like a 3 bar or 4 bar, for example, and we set that value. So This is the name, and this is the switching pressure. So we link this port to the supply port of the cylinder. If we simulate manually, because our DCV is able to be simulated with manual operation, so you can see the way this valve, this sensor is changing. By releasing, the pressure drops, it becomes blue, which means the pressure drops and it changes. By supplying, the line comes in red, which means the pressure has increased. So now let us think how to control, how to turn this solenoid on or off. Just like the way we turn on and off the motors, the motors, the lamps, the whatever, the contactors. So it's an output device like the others. So we just need to think how to turn it on and off. Remembering that when we turn it off, we are changing the position. When we turn it on, we are changing the position. So it depends. So let's go to the control circuit, which is electrical control circuit. And I prefer to use American standard, which is also known as ladder. It needs power line, which is 24 line. And it also needs a 0 voltage, which is okay, like that. So we have to put a normally closed push button switch, which will be considered as an emergence stop. It's normal. When you are designing a circuit, you have to think how to stop the system immediately in case there is an emergency situation. Okay, and we need a start. Remember that we are supposed to use 2 starts. So this will be considered as start 1 and we need also a start 2. Call it start 2. Let me try to adjust. So we are going to ignore the use of pressure sensor, which means we are going to connect the component without this pressure sensor to see the way it works without that pressure sensor. So this is a coil called CR, and we link the switches with the coil, and a switch will also be provided to the solenoid, and we have to link this solenoid to the pneumatic component, which is that one. So we link it solenoid, and we need now the contacts. This is a contact to work as a hold-on. So we link it with CR, and we take the same contacts, and then it is going to the solenoid, and we are going to link it again to the CR. So trying to simulate without the sensor here and to see the way it works. If we press start 1, nothing happens. If we start 2, nothing happens unless we press both starts. Now the cylinder can extend, but it remains there. Even if we release here, it will not come back because we have a hold on here. For the cylinder to retract back, we have to open the circuit by opening the normally closed switch. Let us do it once again with the animation. Again, we press this one and we maintain it, and then we press S2. Now the cylinder can extend, but releasing this, nothing changes because we have a hold on. So we have to open the circuit using this normally closed switch. So it's clear that we need another normally closed contact to be opening the circuit in case the pressure has been reached, the required pressure has been achieved. So we need now to install a normally closed contact for the pressure switch. So we go to contact and we search for that pressure. It should be a normally closed, which is this one. So here we go and we link. Even if we simulate without linking this contact, that one, nothing will happen again. Try to see. Nothing. Can you see? It will not come back unless we open here. So in order to make it to come, we have to link this contact to PS, which is pressure switch, and this time it is going to work. Let's maintain this one and we press S2. You can see that it goes and it comes back. We do it once again, it goes and it comes back. By simulating and by having the animation, you know, the system is working. We can even maintain the first one, the start 2, and they manipulate the first one. You can see the system is working. It means by increasing the pressure on this line, it causes the switch to switch off this line. If you enjoyed the video, please subscribe for further videos so you'll be the first to be notified. Thank you very much. Hope to see you soon.